Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course, Malicious Attacks. There are many types of malicious network attacks. We've mentioned some of these attacks in the preceding chapters as they relate to secure computing, but in this section we will better define them. Some attacks are similar to others, making it difficult to differentiate between them. Because of this, I've listed simple definitions and examples of each, plus mitigating techniques, and summarize them at the end of this section. DOS, denial of service, is a broad term given to many different types of network attacks that attempt to make computer resources unavailable. Generally, this is done to servers, but could also be perpetrated against routers and other hosts. DOS attacks can be implemented in several ways as listed here. Flood attacks. An attacker sends many packets to a single server or other host in an attempt to disable it. There are a few ways to accomplish this, including ping flood, also known as an ICMP flood attack. This is when an attacker attempts to send many ICMP echo request pings to a host in an attempt to use up all available bandwidth. This works only if the attacker has more bandwidth available than the target. To deter this attack, configure the system not to respond to ICMP echoes. You might have noticed that several years ago you could ping large companies' websites and get replies, but after ping floods became prevalent, a lot of these companies disabled ICMP echo replies. For example, try opening the command prompt and typing ping.microsoft.com. It should result in request timed out, which tells you that Microsoft has disabled this. Smurf attack also sends large amounts of ICMP echoes, but this particular attack goes a bit further. The attacking computer broadcasts the ICMP echo request to every computer on its network or subnetwork. In addition, the header of the ICMP echo requests will be a spoofed IP address. That IP address is a target of the Smurf attack. Every computer that replies to the ICMP echo requests will do so to the spoofed IP. Don't forget that the original attack was broadcast, so the more systems on the network or subnetwork, the more echo replies that are sent to the target computer. There are several defenses for this attack, including configuring hosts not to respond to pings or ICMP echoes, configuring routers not to forward packets directed to broadcast addresses, implementing subnetting with smaller subnetworks, and employing network ingress filtering in an attempt to drop packets that contain forged or spoof IP addresses, especially addresses on other networks. These defenses have enabled most network administrators to make their networks immune to Smurf and other ICMP based attacks. The attack can be automated or modified using the exploit code known as Smurf.c. Fraggle, similar to the Smurf attack, but the traffic sent is UDP echoes. The traffic is directed to port 7 echo and port 19 charge gen. To protect against this attack, again, configure routers not to forward packets directed to broadcast addresses, employ network filtering, and disable port 7 and 19. These ports are not normally used in most networks. The attack can be automated and modified using the exploit code known as Fraggle.c. SYN flood, also known as a SYN attack. It occurs when an attacker sends a large amount of SYN request packets to a server in an attempt to deny service. Remember that in the TCP IP three-way handshake synchronization, SYN packet is sent from the client to the server, then a SYN ACK packet is sent from the server to the client, and finally an acknowledgement ACK packet is sent from the client to the server. Attackers attempting a SYN flood either simply skip sending the ACK or spoof the source IP address in the original SYN. Either way, the server will never receive the final ACK packet. This ends up being a half-open connection. By doing this multiple times, an attacker seeks to use up all connection-oriented resources so that no real connections can be made. Some ways to defend against this include implementing flood guards, which can be implemented on some firewalls or other devices, otherwise known as attack guards, recycling half-open connections after a predetermined amount of time, and using intrusion detection systems. Xmas attack, also known as a Christmas tree attack or TCP Xmas scan attack. It can deny service to routers and other devices or simply cause them to reboot. It is based on the Christmas tree packet, which can be generated by a variety of programs. For example, Nmap can be used with the -SX parameter to produce this scanning packet. This type of packet has the FIN, PSH and URG flags set, which gives a Christmas tree appearance when viewing the flags in a network sniffer. If the packet is sent many times in a short period of time, it could possibly result in a DOS, which is why I placed this attack in the DOS flood section. But most routers and other devices today will block this type of packet as it is a well-known attack. Otherwise, an IDS IPS solution, if in place, can detect the packet and or prevent the packet from denying service to a router or other device. Ping of death. POD is an attack that sends an oversized and malformed packet to another computer. It is an older attack. Most computer operating systems today will not be affected by it, and most firewalls will block it before it enters the network. It entails sending a packet that is larger than 65,535 bytes in length, which according to RFC 791 is the largest size packet that can be used on a TCP IP network without fragmentation. It should be noted that normally the maximum transmission unit MTU size of an Ethernet frame is 1,500 bytes and slightly less for encapsulated TCP IP packet. Going beyond this requires special means. Now, if a packet is sent that is larger than 65,535 bytes, it might overflow the target system's memory buffers, which can cause several types of problems, including system crashes. Windows computers do not allow ping sizes beyond 65,500 bytes. For example, ping destination -1655 will work, but ping destination -166000 will not work. However, on some systems, the maximum limitation can be hacked in the registry, and there are also third-party applications that can send these larger-than-life packets. To protect against this type of attack, configure hosts not to respond to pings or ICMP echoes. Make sure that operating systems run the latest service packs and updates. Update the firmware on any hardware-based firewalls and update any software-based firewalls as well. POD can be combined with a ping flood, but because most firewalls will block one or more PODs, it doesn't make much sense to attempt the attack, so most hackers opt for some other sort of packet flooding. Nowadays, this was one of the first DOS attacks. It and other attacks such as nuke and WinNuke are considered by the security community to be a deprecated teardrop attack. Sends mangled IP fragments with overlapping and oversized payloads to the target machine. This can crash and reboot various operating systems due to a bug in their TCP IP fragmentation reassembly code. For example, some older versions of Windows are particularly susceptible to teardrops attacks. Linux and Windows systems should be upgraded to protect from this attack. There are also software downloads available on the internet for teardrop protection. Permanent DOS attack generally consists of an attacker exploiting security flaws in routers and other networking hardware by flashing the firmware of the device and replacing it with a modified image. This is also known as flashing or DDoS forward bomb. Works by quickly creating a large number of processes to saturate the available processing space in the computer's operating system. Running processes can be forked to create other running processes and so on. They are not considered viruses or worms but are known as rabbit malware, rabbits or bacteria because they might self-replicate but do not infect programs or use the network to spread. They are all considered DOS attacks, though, due to their ability to stop a system from functioning. DDoS, a distributed denial service attack, is when a group of compromised systems attack a single target, causing a DOS to occur at that host. A DOS attack often utilizes a botnet, which is a large group of computers known as robots or simply bots. Often these are systems owned by unsuspecting users. The computers in the botnet that attack as attackers are known as zombies. An attacker starts the DOS attack by exploiting a single vulnerability in a computer system and making that system the zombie master or DDoS master. The master system communicates with other systems in the botnet. The attacker often loads malicious software on many computer zombies. The attacker can launch a flood of attacks. The attacker can launch a flood of attacks by all zombies in the botnet with a single command. DDoS attacks and botnets are often associated with exploit kits such as the Black Hole Kit and ransomware. DOS and DDoS attacks are difficult to defend against other than the methods mentioned previously in the DOS section. These attacks can be prevented to some extent by updated stateful firewall switches and routers with access control lists, intrusion prevention systems, IPS, and proactive testing. Several companies offer products that simulate DOS and DDoS attacks by creating a test server and assessing its vulnerabilities with simulated DOS tests. You can find holes in the security of your server before you take it live. A quick web search for DOS testing shows a few of these simulation test companies. An organization can also opt for a clean pipe, which attempts to weed out DDoS attacks among other attacks. This solution is offered as a service by VeriSign and other companies. Manual protection of servers can be a difficult task. Try implementing proper DDoS mitigation. Your organization might want to consider anti-DDoS technology and emergency response from an outside source or from the organization's cloud-based provider. Finally, if you realize that a DDoS attack is being carried out on your network, call your ISP and request that traffic be redirected. One special type of DDoS is the DNS amplification attack. Amplification attacks generate a high volume of packets ultimately intended to flood a target website. In the case of a DNS amplification attack, the attacker initiates DNS requests with a spoofed source IP address. The attacker relies on reflection. Responses are not sent back to the attacker bot, are instead sent back to the victim server. Because the DNS is larger than the DNS request, usually it amplifies the amount of data being passed to the victim. An attacker can use a small number of systems with little bandwidth to create a sizable attack. However, a DNS amplification attack can also be accompanied with the aid of a botnet, which has proven to be devastating to sections of the internet. During the period when attack was carried out, the primary way of preventing this attack is to block spoof source packets. It can also be prevented by blocking specific DNS servers, blocking open recursive relay servers, rate limiting, and updating one's own DNS servers. Often, finally, make use of the domain name security extensions DNSSEC, which are specifications that provide for origin authentication and data integrity. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.